capturing them in
the year
action before they became
1951,
celebrated
the world
aces,
caught in the chill of the Korean War,
joining
and
the
you are
protective
soaring
screen.
above the jagged, ice-bitten skies that loom
We
over
get
the
a rare
Yalu
glimpse
River,
into the operations
the
of the
stark
56th
frontier separating
and 4th
North Korea from China.
Ramrod to Emden is
This
a genuine
narrow corridor of airspace, deadly, infamous,
artifact of the air
whispered
war.
about in every briefing is known
It
simply
preserves
as MiG Alley.
a
For
crucial
the
battle
aviators
of
the Soviet
strategy and
64th
courage was
Fighter
being done.
Aviation Corps, especially
Robert
the
S.
hardened
Johnson.
World War II veterans covertly dispatched to this front. The
Moment
heavens
in
should have
time,
belonged to them.
showing the
They command the MiG-15, the sleek
fighter
silver
groups,
predator
and
that
even
sent
see the
shockwaves through
distinctive
Western
twin-boomed
intelligence the moment it appeared. With its swept wings and lethal posture, the aircraft seems almost alive, an aerial spearhead. On paper, and even more convincingly in the raw violence of vertical combat, it surpasses
Fulfilling a
anything the
promise
Americans have fielded.
to bring the bombers
It
home.
climbs with ferocity. It reaches heights the enemy can only envy. And its brutal 37mm cannons can
The
shred
film
a
The
bomber with a
Thunderbolts,
single
Ramrod
well-placed
to
burst.
Emden.
Opposing them are the Americans in their F-86 Sabres. Elegant machines, yes,
Capturing
but
the
at this
meticulous
precise
planning, the tense
historical
pilot
crossroads,
briefings, and the roar of engines on the
undeniably
airfields
outclassed.
of England.
The Sabre can't follow the MiG's ascent. It can't touch its service ceiling. Physical laws themselves are not the fate of the Soviet fighters. Should one of them find danger creeping up behind, all he needs to do is pull back on the stick and rise. Up there, in the thin, trembling air, where sabers wheeze and folder, the MiG finds its sanctuary. A sanctuary so decisive, it should guarantee supremacy. But then comes a Tuesday afternoon in late spring, an afternoon when the sky decides to break its own rules. It begins with bewilderment so deep it will send ripples all the way to Moscow. Captain Nikolai Sutyagin, destined to become the leading ace of the conflict, heads a 4-ship patrol of MiG-15s. The air is crystal clear. Visibility stretches endlessly. Far below, the rugged Korean landscape lies crumpled like crushed parchment. And there, perhaps 5,000 feet beneath them, Sutyagin spots a formation of American sabres. The scenario is ideal. Soviet doctrine prescribes a simple formula. Dive with fury, unleash the heavy cannons, and then rocket back upward before the Americans can lay a hand on you. The classic boom and zoom, built entirely on energy advantage. Sutyagin signals the strike. 4 silver arrows roll over and plunge. Their speed climbs, 600 mmHg, then 650, the airframe shuddering, straining against the sound barrier. They dive like avenging spirits upon the sabers. The Americans snap into evasive maneuvers, scattering like a broken flock. Sutyagin selects a target. He aligns the rough optical sight and fires. The cannons thud. Bright tracers carve orange paths through the sky, but the shot is off. The angle was too aggressive, the closing velocity too great. No matter, he still holds the upper hand. He yanks back on the stick. G-forces crush him. The MiG responds instantly, its Klimov engine screaming as it converts speed back into height. He rises, fully expecting the Sabre to dwindle below him, powerless to pursue. But when he glances back, the Sabre isn't shrinking. It's following. It should be impossible. The Sabre is heavier, weaker in thrust, doomed to bleed energy and stall out. Yet the American is still behind him, clinging to his tail. Sutyagin's mind races, but the true shock lands a heartbeat later. Now thousands of feet higher, twisting under heavy G-load, Sutyagin presents a tiny, dancing silhouette. At such distance, striking a maneuvering jet with machine gun fire is a statistical fantasy. The human eye cannot gauge that lead. At these speeds, at these angles, marksmanship dissolves into chaos. And yet tracers zip past his canopy. Not wild, desperate shots, but accurate ones. A precise string of 50 caliber rounds tears into his wingman's aircraft. Smoke erupts. The hit is clean. calculated, fired from a position and range that defy everything known about aerial gunnery. Sutyagin watches, stunned, as his comrade spirals downward. Rage doesn't come, only confusion. He knows the Browning gun's limitations. He knows their effective reach. What he just witnessed should never have happened. It feels like a phantom shot, some freak, one in a million accident. He calls off the mission. The MiGs flee toward the safety of the Chinese airfields. His pulse hammers, not from exertion, but from a creeping realization. The rules of engagement have shifted, silently and without explanation. Back at Antung Airfield, chaos reigns. Pilots stumble out of their cockpits, lighting cigarettes with trembling hands. And it wasn't just Sutyagin's flight. Everywhere in the sector, Soviet airmen report the same impossible encounters. They executed their vertical escapes. They climbed out of reach and still got hit. Dear friends, if this video has reached you, it's not by chance. Right now, click the subscribe button and the notification bell. Write a number from 1 to 5 in the comments. I will personally respond to the first 50 comments and make sure to watch the video until the end. Ground crews swarm the wounded MiGs that manage to limp home. They inspect the damage. The bullet holes are clustered tight, far too tight. That's the signature of a marksman, not a pilot spraying rounds in a frantic turn. To achieve such grouping against a target screaming at 600 mph, pulling 4Gs, verges on the unreal. No Soviet training prepared them for this. Debriefing officers interrogate them relentlessly. Did you slow down? Did you fly straight? Did you give them a clean shot? No, the pilots insist. They were maneuvering. They were climbing. They were far beyond the Americans' effective range. Political officers, the commissars suspect cowardice or incompetence. They refused to accept that American aircraft could perform such miracles. They accuse the pilots of letting sabers creep too close. But the veterans know their truth. They saw the tracers bend toward them from distances where the American jet appeared nothing more than a speck on the horizon. It is as though an unseen hand is guiding those American bullets. Before we plunge into the labyrinth of the investigation that would soon consume the entire Soviet High Command, imagine this. If your curiosity pulls you toward the hidden technologies and the shadowed histories that shaped the 20th century, then you would want to be part of the world of Cold War impact. That is where the archives are pried open, where the forgotten truths, those that slip through the cracks of official history books, are brought into the light. Picture the scene. The sun is sinking behind the Yalu River, leaving the water glowing like molten metal. Yet far below the earth, the command bunkers of the warring armies remain lit, humming with tension. Every flicker of those lamps is a reminder. The stakes could not be more severe. To grasp the drama unfolding, you must place yourself squarely in the mindset of the Soviet Union at this razor-thin moment in time. The year is 1951, a world balanced on the brink of nuclear annihilation. Stalin still rules, and his paranoia has sharpened to a lethal point. The Korean War has become a proving ground, a silent testing arena. And here lies the central fear. If the Americans can dominate the skies above Korea, then their bombers can slice through Soviet airspace just as easily. That would mean the enormous and costly air defense network the USSR is constructing. One built with deep faith in the MiG-15 might be catastrophically flawed. The MiG-15 was their hidden trump card, the surprise intended to equalize the West's sheer numerical advantage. But if the Americans have found a way to knock these jets out of the heavens, despite the MiG's aerodynamic superiority, then the global balance of power is shifting in a terrifying direction. Reports begin oozing through the Soviet chain of command, creeping their way to Moscow. The wording is cautious, deferential, nearly trembling, because who would dare bring Stalin bad news? They describe bold American tactics, unnervingly precise gunfire. Yet between the lines, You can almost hear the panic, like a heartbeat quickening in the dark. Loss rates are rising, and sharply. In the early days of the war, the arrival of the MiG-15 had shocked the United States so deeply that the B-29 bombers stopped flying in daylight altogether. American aircrews were terrified. But now, week after week, it is the F-86 Sabre pilots who are clawing their way to dominance. They are achieving kill counts that seem to mock the performance charts of their own aircraft. And somewhere in the mess halls of Antung, a chilling theory starts whispering itself into existence. Pilots murmur it behind their hands. They say the Americans must have invented some kind of new weapon. Maybe, they suggest, it is a proximity fuse hidden inside the .50 caliber bullets. Or perhaps some kind of ultra-high-velocity ammunition that flies so fast it barely requires any lead calculation. And then comes the theory that makes their blood run cold. What if the Americans have devised an entirely new way to control their aircraft? Something the Soviet designers cannot even fathom. From that moment on, each time a Soviet pilot straps into his cockpit, the earlier confidence is gone. The swagger of flying the superior machine has evaporated like frost under a torch. Now they look at the sky and see danger everywhere. They know that one misstep, just one, and if they slip into the Sabre's mysterious zone, they will be annihilated with uncanny, almost mechanical accuracy. That is what they begin calling it, the zone. An invisible bubble around the American jets. Enter it, and you die. Speed cannot save you. Altitude cannot save you. Once inside the zone, the Americans simply do not miss. General Georgy Lobov, commander of the 64th Fighter Aviation Corps, feels the pressure bearing down on him like a mountain. Moscow demands results. American aircraft shot down. Soviet pilots returning home alive. Instead, Lobov is writing condolence letters and watching his finest men disappear into the Korean hillsides in flames. So he changes tactics. Get closer, he orders. Don't fire until you can see the rivets. He is convinced the problem is poor Soviet marksmanship, that his pilots are firing from too far away while the Americans maintain stricter discipline. But he is wrong. The crisis reaches a breaking point when an experienced flight leader, a man who had once battled the Luftwaffe itself, engages a lone Sabre. The duel becomes a vertical rolling scissors, a dizzying aerial dance where two planes spiral around one another, each trying to force the opponent into overshoot. The Soviet pilot executes each move flawlessly. He forces the Sabre ahead of him, lines up his shot, and then watches in disbelief as his shells streak past harmlessly. The optical sight in his MiG-15 vibrates and bounces. He must estimate the lead by eye. And he guesses wrong. Suddenly, the Sabre reverses. It behaves as if immune to the laws of energy. Heavy with inertia, it should not be able to pull its nose around. But it does, and it points straight at the MiG. The Soviet pilot brakes hard, pulling 5 Gs, confident he is safe. The deflection is far too great for the American to hit him. Then the tracers arrive. They carve a deadly line across his fuselage, slicing through the hydraulic systems. The controls go limp. He ejects, flung into the freezing wind, tumbling helplessly. From his parachute, he watches the Sabre fly away. It had not fired a desperate spray. It had fired a short, 2-second burst, and every bullet had struck home. This was not luck. This was a system. At that moment, the Soviets grasp that they are battling a phantom something invisible inside the skin of the F-86 Sabre. And until they uncover the secret, the slaughter in MiG Alley will continue. The mystery is no longer a tactical puzzle. It is a strategic emergency. The Kremlin issues the directive. Find out how they are doing it. Discover why they never miss. The hunt begins. But the investigators look in all the wrong places. They search for a new gun, a new engine, never imagining that the real secret is far smaller and vastly more intricate than anything they can conceive. The mystery shifts from the frigid upper atmosphere to the frozen mud of North Korea. The Soviet Union unleashes its technical intelligence apparatus with a fury usually reserved for nuclear espionage. Special recovery teams are assembled, no common infantrymen, but engineers and GRU intelligence officers, accompanied by Chinese security units. Their orders are absolute, the kind that could carry a death sentence for failure. Bring us a Sabre. Whenever an F-86 crashes, which is rare, these teams race to the site, competing against American combat rescue helicopters, often while artillery shells rain down. They must reach the wreckage before the Americans reduce it to dust. For the Americans understand precisely what must be protected. When a Sabre falls behind enemy lines, U.S. Navy Corsairs and Sky Raiders often swoop in immediately, strafing and napalming the crash site, incinerating their own technology rather than letting it fall into Soviet hands. This scorched earth urgency only deepens Soviet suspicion. What are the Americans hiding? Then, in the deep winter of 1951, comes a breakthrough. An F-86A Sabre crashes into the tidal flats near the coast. Mud smothers the fire. The pilot ejects and is whisked away by a rescue helicopter, but the machine remains intact. The tide rises, concealing the shattered aircraft from American spotters. Under the cover of night, hundreds of Chinese laborers and Soviet advisors drag the wrecked jet from the muck. They load it onto a flatbed truck, cover it with hay, and escort it north across the Yalu River into the comparative safety of Manchuria. From there, it is placed on a train bound for Moscow, its destination, the Central Aerohydrodynamic Institute, and the secret weapons bureaus. The autopsy begins immediately. Soviet engineers swarm the aircraft like surgeons dissecting a fallen giant. They peel off skin panels, extract the engine. But the ballistic specialists head directly for the nose, for the guns. There, they expect to find the miracle weapon that has been shredding MiG-15s with alarming precision. What they uncover is disappointing. 6 Browning M3 machine guns. They dismantle them on sterile white laboratory tables, measuring the rifling, testing spring tension, examining firing pin metallurgy. The report delivered to Stalin is bewildering. These weapons are no super technology, merely updated 50 caliber guns from World War II, with a slightly increased rate of fire at 1/200 rounds per minute. Crude by Soviet standards, relying purely on kinetic impact. Not even explosive shells, unlike the MiG's powerful 37mm cannon. Confusion spreads. This? They ask. This is what is killing us? They inspect the ammunition next standard ball, tracer, incendiary. No proximity fuses, no guidance mechanisms, no exotic propellants. If the gun is simple and the bullets unsophisticated, then the power must lie in the aiming. So attention shifts to the cockpit. The canopy is shattered, the instrument panel corroded by salt water and impact. But perched behind the armored glass is a black box, an optical sight. The technicians remove it carefully. It is labeled ANCM. At first glance, it appears to be a standard reflector sight, like those used by Germany in the war, similar to what sits in every MiG-15. But when they open the casing, they find a dense jungle of wiring and vacuum tubes, something that resembles a miniature computer more than a gun sight. Tiny gyroscopes, magnetic amplifiers, a labyrinth of circuitry. Yet the unit is ruined. The delicate gimbals crushed by G-forces, the vacuum tubes shattered. The Soviets can see what it is, but cannot bring it to life. They cannot power it on to witness the ghost their pilots keep describing. They attempt to reverse engineer it. And in doing so, they notice a connection. The sight is linked to a small intake on the jet's nose. A radar. Radar ranging, a chief engineer mutters. They're using radar to get distance. Major revelation, but it leads them down a dangerous, incorrect path. They assume the radar merely helps the pilot judge range or resize the reticle. The Soviets have similar ideas on their drawing boards. But range finding alone does not explain lead, does not explain predicting where a MiG will be 2 seconds into the future. So the investigation turns to the pilots. In cold interrogation rooms inside North Korean prison camps, captured American pilots are questioned. They are wounded, exhausted, frightened. Soviet interrogators, speaking through translators or broken English, do not ask first about troop movements. They ask about the box. How do you aim? The interrogator demands. Do you use the rudder? Do you calculate deflection by hand? The Americans, many of them instructed to reveal nothing about the A-series sights, either feign ignorance or speak truthfully, that they do not fully understand the system themselves. I just put the pipper on the target and pull the trigger, one says. It drives the Soviets into a frenzy. Liar, they shout. At 600 miles per hour, if you put the pipper directly on him, you will fire behind him. You must lead. How do you calculate the lead? I don't, the pilot repeats. The box does it. The box does it. That phrase crawls back to the Kremlin. It spreads through Soviet air bases like wildfire. Soon, pilots no longer refer to it as a gun sight. They call it the electronic brain. Rumors mutate. Some believe the Americans have connected the radar directly to the flight controls, so that once a pilot locks onto a MiG, the F-86 Sabre flies itself, transformed into a robot assassin. The Soviet pilots grow convinced of one chilling idea, that the American aviator isn't really flying at all, that he's simply the passenger of a machine, waiting to press a button when a little red light blinks. And this thought frightens them more than any dogfight ever could. After all, you can outmaneuver a man. You can confuse him, intimidate him, break his nerve. But how do you scare a gyroscope? How do you outthink a calculator? Another rumor spreads like frost on glass, that this electronic brain can see in darkness, can pierce clouds, can hunt through storms. Imagine being a Soviet pilot accustomed to hiding in the protective embrace of heavy cloud cover, only to feel suddenly exposed, as if American radar eyes are slicing through the fog, tracking you, solving firing equations while you are blind. What would you feel in that moment? Panic becomes common, and Moscow, desperate for an answer, demands that the Soviet industry replicate whatever sorcery the Americans are using. They examine their own gun sight, the ASP-1N, a derivative of a British wartime design. Yes, it is a gyroscopic sight, but a sluggish one. When a Soviet pilot throws his MiG into a hard turn, the reticle lags behind like a drunk stumbling after a dancer. It wobbles, it sways. It takes 2 or 3 agonizing seconds to settle. In a dogfight, those seconds are an eternity. By the time the sight stabilizes, the target has already vanished. Naturally, the Soviet analysts assume the Americans must suffer from the same limitation. Physics is physics, after all. Gyroscopes drift, they oscillate, they fall behind. So the analysts come to a simple conclusion. The Americans must be flying smoothly to make their gun sight work. And with that, a new directive is issued, one that will doom many Soviet pilots. If the Sabre depends on smooth flight, then Soviet pilots must shake it. They must fly erratically wild, violent, unpredictable maneuvers to crash the American computer. This becomes doctrine. Yet the irony is tragic. By flinging their aircraft around in chaotic, energy-draining moves, the Soviets are stripping themselves of the very advantage that once guaranteed their survival. They bleed away speed, the golden currency of air combat, all in an attempt to confuse a device they fundamentally misunderstand. They do not realize that the American gun sight does not demand smooth flying, that the innovation hidden within that black box was designed specifically to function amidst the chaos they are creating. Meanwhile, in Moscow, tempers boil over. Stalin is furious. The loss ratios have become intolerable. For every downed American Sabre, Soviet forces are losing far too many MiGs. The exact numbers remain a closely guarded secret, but the trend is unmistakable. Investigations stall. The wreckage that crashes into Korean hillsides is too mangled to reveal how the sight works. The captured pilots know little or refuse to talk. The theories multiply, but they are born from fear, not knowledge. In the minds of Soviet officials, the F-86 Sabre transforms into a kind of robotic phantom, a triumph of American electronics, defeating Soviet aerodynamic purity. An inferiority complex takes root, one that will haunt the Soviet military for decades. Obsession grows. Electronics, automation, cybernetic control systems, anything to catch up to the imagined American lead. And all the while, the truth lies far closer to Earth. By 1952, the air war shifts again. The Americans unveil an upgraded Sabre, the F-86F, and suddenly the mystery only deepens. The kills become tidier, the ranges grow longer. The Soviets find themselves on the defensive, reluctant to patrol aggressively. They cling to higher altitudes, venturing downward only when necessity forces their hand. MiG Alley, which once promised to be a slaughterhouse for American bombers, now feels like a trap for Soviet fighters. Yet the Soviets remain convinced the secret must be a radar-guided autopilot, and they prepare to pour billions of rubles into countermeasures. Radar jammers, anti-radiation systems, chasing a ghost that does not exist. Because the truth is not in the radar. The truth is in a small, spinning component one that solves the most complex mathematical problem in aerial combat instantaneously. While the Soviets hunt for electronic sorcery, the Americans are winning with a piece of analog genius hiding in plain sight. Picture the scene: Soviet generals screaming at their pilots for greater aggression. KGB officers combing through scorched fragments scattered across frozen Korean valleys. And meanwhile, the answer to their torment sits quietly on a workbench in Cambridge, Massachusetts. Not a weapon forged in the fires of the Manhattan Project. Not some extraterrestrial relic retrieved from a crash site. But a mathematical breakthrough conceived by a mind that recognized a simple truth: the human brain has limits. The ghost haunting MiG Alley was born inside the MIT Instrumentation Laboratory, led by Dr. Charles Stark Draper. Doc Draper wasn't a fighter pilot. He wasn't a soldier. He was an engineer who viewed war as a landscape of equations, and he understood something monumental about the jet age long before anyone else did. Speed kills accuracy. During World War II, aircraft typically fought at around 300 km/h. At those speeds, a skilled pilot could eyeball the lead on a turning enemy, rely on intuition Kentucky windage, gut feeling, and still land a hit. But Draper examined the numbers of the jet era: 600 km/h, 1,000 order of closing speeds. At such velocities, the geometry of an intercept transforms faster than the eye can signal the brain, faster than the brain can relay a command to the hand. By the time a pilot sees his moment and decides to fire, the enemy has already vanished from the solution. Trying to compute ballistics at Mach 0.9 isn't difficult. It's impossible. What the pilot needed wasn't a better weapon. He needed a partner, a machine capable of predicting the future. So began the A1 series, evolving into what would become the A4 gun sight. Though to its engineers, it was simply the sight. And its heart was not a microchip, because microchips did not yet exist. Its heart was a gyroscope, but not an ordinary one. Draper had perfected a marvel called the floated integrating gyro. Imagine a small, exquisitely machined spinning top, suspended inside a container filled with thick, molasses-like fluid. That fluid dampens vibration and shields the gyro from the violent buffeting of a fighter jet. It allows the device to sense even the tiniest movement with absolute purity. Here is the real secret the Soviets were desperate to uncover. In ordinary gun sights, the crosshair is fixed. Where the nose points, the reticle points. But in Draper's sight, the reticle, the pipper, is alive. It floats. When an American pilot banks his F-86 Sabre to chase a turning MiG-15, the gyroscopes feel the G-forces, detect the rate of turn, and physically move the projected reticle on the glass. It drifts away from the enemy aircraft. Counterintuitive, isn't it? Why, you might wonder, would the sight intentionally drift away from the target? Imagine yourself in that cockpit for a moment. The answer lies not in mechanics alone, but in psychology. As soon as the reticle slipped off the enemy aircraft, the pilot's instincts surged. To drag the pipper back onto the MiG, he would naturally tug harder on the stick, carving a tighter turn without even realizing it. In chasing that tiny glowing dot across the glass, he was unknowingly aligning his aircraft into the perfect lead angle. The sight-quiet, uncomplaining was doing the math. It measured turn rate, accounted for air density, calculated ballistic drop. It whispered, almost tauntingly, "If you want to hit that MiG, aim here into this empty patch of sky." The pilot no longer needed to estimate anything. He simply had to trust the wandering reticle. But there was still one missing variable, a crucial one: range. Without precise distance, the equation remained incomplete. During World War II, range finding was clumsy and slow. Pilots had to twist a knob to match the enemy's wingspan in their reflector sights, a stressful, error-prone method at 400 miles per hour. Then came the APG-30. The Soviets had discovered this radar in the wreck they recovered, but they misunderstood its purpose entirely. It didn't fly the airplane. It didn't peer through clouds. It was a compact, straightforward range-finding radar tucked into the Sabre's nose intake. As an American pilot closed on a MiG-15, the radar locked onto the target automatically and delivered exact distance, perhaps 200 feet, to the gyroscopic computer. That single measurement completed the circle. Suddenly, the system became a closed-loop instrument of terrifying precision. The gyroscopes sensed the pilot's turn. The radar supplied the distance. The computer generated the ideal aim point. And what did the pilot have to do? Nothing complicated. He merely flew so that the glowing orange diamond settled onto the shimmering aluminum skin of the MiG. No mental trigonometry, no sweating bullets over deflection angles. Just put the thing on the thing and squeeze the trigger. This alchemy turned average pilots into lethal marksmen. It pushed good pilots into the realm of aces. While Soviet flyers struggled with jittering optical sights, performing frantic geometry in their heads as blood drained from their vision under 5Gs, their American opponents were quite literally playing something that felt like a crude 1950s version of a video game. The technology was so ahead of its time that the U.S. Air Force was terrified of losing it. Now the scorched earth tactics made sense. Pilots were warned. The sight is more valuable than the airplane. And they weren't exaggerating. The floated gyroscopes inside the sight demanded manufacturing tolerances down to 1/1,000,000th of an inch, an industrial feat the Soviet Union, for all its steel and heavy machinery, simply could not achieve in the early 1950s. Two philosophies now stood in stark contrast. The MiG-15 embodied the Soviet mindset. Build a muscular hot rod big engine, massive cannon, minimal complexity, and depend on raw pilot aggression. The F-86 Sabre embodied the American philosophy. Build an integrated weapon system. Merge human and machine. Strip uncertainty out of the equation. The Soviets hunted for a robot airplane. They never realized they were facing the first true cyborg weapon of the Cold War. The Sabre pilot was no detached passenger. He was the living actuator of Dr. Draper's mathematical masterpiece. Yet even this marvel had a flaw, a vulnerability the Soviets, blinded by paranoia, never exploited. The A4 sight needed time to settle. When the stick was jerked violently, the liquid inside the gyros needed a moment to stabilize. If the aircraft maneuvered too erratically, the reticle would skid or bounce across the glass. The Americans knew this well. Their training reinforced a certain elegance in motion. "Squeeze the stick," instructors urged. "Don't yank it." They flew with a smoothness the sight rewarded with uncannily accurate fire. Soviet observers misread this grace. They assumed it was arrogance, or, as earlier theories claimed, they believed the American robot required a steady platform. So they ordered their pilots to do the opposite, fly violently, shake the airframe, disrupt the supposed automation. And by doing so, they sabotaged themselves. Every brutal maneuver bled precious energy. The MiGs slowed, and the moment they slowed, even for a heartbeat, the American radar locked on, the gyros steadied, the dot drifted onto target, and the Sabre unleashed a burst of 6 50-caliber guns, spitting 600 rounds with ruthless efficiency. The enigma that had tormented the Kremlin was not sorcery at all. It was the triumph of systems engineering. The dawning understanding that in the modern era, the deadliest part of a fighter jet was no longer the cannon or the engine. It was the black box that told the pilot where to point them. But secrets in wartime are fragile. As the conflict dragged on, more Sabres took damage, more crashed. Eventually, inevitability caught up with American luck. One day, a Sabre went down, and this time, it neither burned nor detonated. It settled belly first into a soft sandbank on a tidal flat, the rising tide gently embracing it like a specimen preserved in a jar. The pilot was captured, and the recovery team arrived before American bombers could obliterate the wreck. They wrapped cables around the submerged machine, hauled it from the sucking mud, and inside the cockpit, though the canopy was cracked, the black box had survived. The gyros were still floating in their oil. At last, the Soviets had their treasure. They sealed it in a crate and flew it directly to Moscow, to the design bureau responsible for gun sights. The nation's top engineers gathered with crowbars in a sterile, high-security room. They prepared to pry open the American ghost, convinced they would uncover some impossible secret weapon. What they discovered would not merely explain the massacre of MiGs over Korea, it would force them to confront a terrifying truth about the technological gulf yawning between East and West. Late 1952, NI-17 Research Institute. A wooden crate sits under brutal white lights. The room is filled with the Soviet Union's finest minds in optics, ballistics, radar. The tension is so thick it feels almost solid. They remove the lid. Inside, nestled in American packing foam, lies the electronic brain. Damaged, yes, but intact. Salt water had not yet seeped into the delicate internals. The engineers commence the dissection. They peel back the casing of the ANCM site. They expect something alien, bizarre, perhaps a miniature nuclear power cell or a leftover miracle from German V-2 rocket scientists. But what they find hits them far harder. Inside lies not sorcery, but precision. A level of immaculate craftsmanship that does not exist anywhere in the Soviet industrial cosmos. When the lead engineer opens the gyroscopic assembly, he stops. He places a component under a microscope. He calls the others over. One by one, they peer through the lens. A heavy silence fills the room. The shock is not that the technology is supernatural. The shock is that it is flawless. They are staring at the heart of Dr. Draper's floated integrating gyro. The clearance between rotor and housing is measured in microns. The fluid inside has chemical properties the Soviet industry has never produced. The wiring is so fine, it resembles the art of a jeweler, not the output of a factory. And in that moment, a devastating realization settles over the engineers like a winter fog. The Americans did not dominate MiG Alley because they had superior pilots. They did not prevail because their aircraft were faster. They prevailed because their machinists were better. The legend of the ghost bullets was never mystical. It was evidence of a widening technological chasm between two superpowers. The United States had mastered the mass production of precision instruments. Imagine for a moment what it means to take delicate laboratory experiments devices that normally sit under glass, surrounded by white coats, and bolt them into the cockpits of thousands of fighter jets, machines thrown into brutal combat as if they were disposable. That is what the Americans had done. And when Soviet engineers delivered their findings to the Kremlin, they stripped away every layer of propaganda. Their report was blunt, almost heretical. The American device, they explained, calculates the lead angle automatically, feeding off radar inputs. It produces a firing solution so quickly, the report states, that the pilot becomes little more than a servo mechanism. Stalin's reaction is immediate and terrifyingly predictable. He has no patience for talk of tolerances or microns. He's not interested in the challenges of precision engineering. He slams his fist upon the desk and thunders, "Copy it! Screw for screw, wire for wire. Make it look exactly the same, and put it into our MiGs." And with that, he unleashes one of the most agonizing chapters in the history of Soviet aviation. Factories across the USSR mobilized to replicate the American A-4 gun sight, christening their clone the ASP-4N. Outwardly, it is indistinguishable from its American counterpart. It slides neatly into the cockpit of the new MiG-15, just as the original fits perfectly into the Sabre. Same casing, same glass, same dials, same radar hookups. But inside, deep inside, reality hits like a hammer. To build floated gyroscopes, you need rooms purged of dust, atmospheres held to temperature tolerances within fractions of a degree. You need metallurgical purity that borders on the sacred. You need craftsmanship closer to Swiss watchmaking than to mass military production. And the Soviet industrial machine, magnificent though it is, was constructed to forge tanks, engines, rugged tractors by the tens of thousands. These are factories built for brute output, not microscopic perfection. So the rush begins. Substituted materials replace precise American alloys. Tolerance levels deemed good enough for a tractor are approved for a gyroscopic computer. Quotas loom, and party officials demand volume, not finesse. The result is tragic. The ASP-4N becomes a zombie imitation shaped like the American masterpiece, humming like it, but lacking the soul of the elegant mechanism it sought to copy. When the new sights arrive at the front and are installed in the MiG-15s and MiG-17s, the pilots erupt with excitement. At last, they think, we have the magic eye. The playing field is finally level. They take flight with renewed confidence. They engage sabers, lock onto radar signatures, watch as the pipper forms, and then begins to drift. The Soviet gyros are subtly unbalanced. The damping fluid is contaminated. Under the violent G-loads of combat, the fragile mechanism scrapes its housing. The floated behavior collapses. The reticle no longer glides. It jerks. It stutters. It lies. Picture the horror of a Soviet pilot in 1953. He dives on an F-86 Sabre, trusting this new electronic brain. He aligns the pipper. He squeezes the trigger. And the shells miss by hundreds of yards. The sight insists he is dead on, but the corrupted mechanics betray him. He tries to adjust, but the reticle lags, jitters, trembles with every fluctuation of radar input. Back on the ground, pilots return seething with fury. "The box is broken," they shout. "It's trying to kill us." Maintenance crews attempt calibration, but they are fighting physics, not misalignment. You cannot tune precision into a device that was never precise to begin with. The reputation of the Soviet clone collapses almost instantly. Trust evaporates. Pilots begin physically reaching up into the cockpit, caging the gyro, locking it in place, reducing this supposedly advanced computer to nothing more than a fixed 1945-style crosshair. They return to Kentucky windage, to guessing, to instinct. Across the valley, American pilots flying the upgraded F-86F Sabres soar with the original device, smooth, reliable, precise. Their sights hum with mechanical perfection. They trust their machines. Confidence becomes lethality. For the Soviet Union, the shock is absolute. They realize a devastating truth. You can steal blueprints, you can even steal the device itself, but you cannot steal an industrial base capable of building it. They were attempting to race a Ferrari with the engine of a tractor. As the war enters its final months, the skies over Korea fill with these new F-86F Sabres, now operating as a fully integrated weapon system. Kill ratios surge. Some accounts whisper that they reached 10-1 in favor of the Sabre. Historians argue over the precise number, but no one disputes the direction of the trend. The MiG-15, so aerodynamically brilliant, was being torn apart. Soviet generals stare grimly at the reports. They understand something foundational has shifted. A new front has opened. Warfare is no longer measured solely in horsepower, climb rate, or armor thickness. It is about information. How quickly you can process it, how precisely you can act on it. The American gun sight is calculating speed, distance, angle, air density-solving equations faster than any human could dream. The Soviets, despite their courage, are fighting a manual war in an automatic age. In a final desperate attempt to regain the upper hand, Soviet design bureaus pivot. If they cannot win the electronics war, they resolve to lean into the one domain where they reign supreme: brute force. They begin sketching machines that fly so fast, so high, so violently, that no computer on Earth can solve the firing solution in time. Imagine the mood inside the Soviet design bureaus as they pivoted, almost in panic, toward a new direction. What do you do when a problem seems unsolvable? You run from it. And that is precisely what happened when they launched work on the MiG-19 and the MiG-21. If we cannot outthink the Americans, they reasoned, we will simply outrun them. Speed becomes their mantra. Velocity is the finest armor, they reassure themselves. Fly at Mach 2, and their tiny gyroscopes will never keep up. Yet deep inside NI-17, the engineers know the uncomfortable truth. They have seen the future glowing inside that wooden crate from Korea. They understand that the mystery revealed on those battlefields was only the prologue. They know, with a kind of dread, that computers will inevitably get faster, that missiles will only grow smarter, and that without mastering the electron and the gyro, the Soviet Union is already losing a Cold War that has barely begun. The American sight wasn't just a clever device. It was a warning flare arcing across history. And so, when the thunder of guns finally dies over the Korean peninsula in July 1953, leaving behind only an uneasy armistice, a deeper struggle is already igniting in the sealed archives of both the Kremlin and the Pentagon. Jets glide back to their airfields. Pilots return home. The skies over the Yalu River fall quiet. But the secret war, the war for information, is only beginning. To this day, the final air war scorecard remains a battlefield of its own. American propaganda proudly boasted a staggering 10-1 ratio. 792 MiG-15s downed in exchange for just 78 Sabres. Modern historians, peering into once-sealed Soviet documents, argue for a more modest figure: perhaps 4-1 against Soviet airmen, and nearly 1-1 when facing their Chinese counterparts. But these numbers, dazzling or sobering as they may be, obscured the deeper verdict. Because the true victory wasn't tallied in wreckage. It was psychological, a blow to the very soul of the Soviet military-industrial machine. The enigma of the A4 site planted a seed of doubt so deep that it would metastasize through the next 4 decades. It proved something revolutionary. In the new age of war, elegant aerodynamics, the perfect wing sweep, the powerful engine, no longer guaranteed dominance. By every aerodynamic metric, the MiG-15 had the upper hand over the F-86 Sabre. It climbed higher. It gained energy faster. In a pure contest of machines, it should have been the victor. And yet it wasn't. Why? Because the Americans had brought a computer to what the Soviets believed was still a knife fight. The collapse of the ASP-4 Newtons, that tragic Soviet clone, sent shockwaves far beyond the Korean front. It nudged the entire Soviet Union into a defensive crouch from which it never fully recovered. Instead of forging their own breakthroughs in microelectronics and precision systems, they became fixated on espionage and imitation. They spent billions of rubles weaving vast spy networks to pilfer Western designs, only to discover they lacked the industrial purity to reproduce them. It was a technological cargo cult. They could carve the outline of the microchip, but not its flawless silicon. They could assemble the shape of the gyroscope, but not the purity of its fluid. This obsessive imitation became the Cold War's recurring motif. You see it in the Tu-14444, the Concordski, eerily similar to the Concorde yet louder, riskier, and less refined. You see it in the Buran space shuttle, nearly a mirror of the American orbiter, yet destined to fly only once. The episode in MiG Alley was the first unmistakable omen of the Soviet Union's downfall. Their economy was a colossus built for mass, millions of tons of steel, legions of tanks, colossal hydroelectric dams. It was a world engineered for giants. But the future of conflict belonged to the tiny, to the transistor, the micro-switch, the floating gyro. And the rigid, quota-driven Soviet command economy simply couldn't nurture the dust-free, temperature-perfect sanctuaries that modern information technology required. The F-86 Sabre and its mysterious little sight signaled the death of an era, the end of the Night of the Air. Once, the fighter pilot was a romantic warrior, a poet with wings, the heir of the cavalryman. He hunted with instinct and killed with reflex. But after this moment, the transformation began. The pilot slowly evolved into a systems manager. The A4 sight was the distant ancestor of the heads-up display, the primitive forebear of the F-35 Lightning's aim assist algorithms. It marked the first footsteps toward a world where the aircraft thinks for itself, and the pilot becomes the final vote in the loop, authorizing when a target dies. Walk today into the National Museum of the U.S. Air Force, stand beside an F-86 Sabre, peer into its cockpit. Everything looks cramped, mechanical, almost quaint. And that legendary A4 sight, it resembles nothing more than a bit of metal and glass. But look closer. You are staring at the hinge on which history swung. That small black box did more than shoot down MiG-15s. It shattered the Soviet doctrine of brute force. It proved that the greatest weapon in war is no longer the largest cannon. It is the cleverest chip. The pilots of the Soviet 64th Fighter Aviation Corps carried the memory to their graves. They remembered the impossible American shots, the tracers that bent like witchcraft, and the chilling revelation that their enemies weren't merely fighting, they were calculating. The riddle was finally solved, but the lesson was catastrophic. For the next 40 years, the Soviet Union chased the ghost of American technology, running a race it had already lost high above Korea in 1951.